Our today's topic is cryptography, and in cryptography, we are trying to address encryption, hashing, and salting. These three topics, they cover data security, data integrity, and password protection. So first, let's talk about encryption. Encryption is a process of scrambling information in a way that someone can unscramble, provided that the person has a key. So when you have a data, you just encode it with the encryption key, give it to someone else, and you also give a key to decode the information, and that person can easily decrypt the information. Process just converts the original plain text information into alternative form, which is known as ciphertext. It might be possible to decrypt the message without the key, but it takes a lot of resources and skill if encryption was well designed. An authorized person can easily decrypt the message with the key. So encryption is a two-way function. When you encrypt something, you're doing so with the intention of decrypting it later. So you have a message, then you encrypt the key. It'll become a scrambled information. Nobody without the key can read it, and the person or the system who has the key can decrypt and read the information. Using a cipher, which is also known as an algorithm used in encryption, we'll just come up with the key or keys depending on what encryption algorithm you use, and use that information to encrypt and decrypt the data. So let's see different types of encryption. Actually, let's look at an example. So I wrote a pretty simple script here. Let's say just enter the word hello. Then you just provide the sift value, how you want to sift the numbers. And let's say just 5. Then it will print something like MJQQT. So it's sifting every character by 5. So H becomes M, E becomes Z, L becomes Q, and then O becomes T. So this is a simple form of encryption. So somebody who receives MJQT might not realize that it was for hello, but someone who has the knowledge that it was encrypted and they have a key, which is 5 in this case, they can easily sift back to the original message, which is hello. So in this case, sift is the algorithm that we use, and 5 is the key that used in the encryption. So there are two types of encryption, asymmetric encryption and symmetric encryption. So let's talk about symmetric encryption first. Asymmetric encryption, also known as a public key encryption. In this encryption, we use one key to encrypt the data and another set of key to decrypt the data. Encryption is one way. Neither party can decrypt the message using the same key that was used to encrypt the message. And this is the foundation of the public key infrastructure. And for data security, public keys should always encrypt the data, and private keys should always decrypt the data, not the other way around. But if you're just signing some kind of information or the web page or anything, then private key encrypts the hash, and public key decrypts to find the authenticity of the sender and verification of the data integrity by comparing the hash. So you, during the digital signing, first you use the private key to encrypt the hash, and then you'll give to someone else, and your public key is available to everyone. So that person with the public key can decrypt the hash, and now the person who's holding the public key has a hash value, and then also the message that you sent. So that person now can generate the hash out of the information and compare the hash that was decrypted using the public key. So if both hash matches, then it's confirmed that the sender was the authentic. We will talk more about it later, and also in a different video when I talk about SSH and SSH key authentication. So RSA, DSA, and ECDC are probably mostly use symmetric encryption techniques. Let's talk about symmetric encryption. So symmetric encryption, also known as a shared secret encryption or a private key encryption sometimes, it uses the same key to encrypt the data and also decrypt the data. Each party has its own key to encrypt and decrypt the message. So you're just sharing one shared, so you're just sharing one key. That's why it's called shared secret encryption. The shared secret key is created through a process known as a key exchange algorithm. The algorithm makes it possible for each party to combine their own private data with the publicly available data from the other party, and they arrive in the same identical key. They use something of Diffie-Hellman algorithm to come up with the identical key. Usually it's used along with this symmetric encryption during and after SSL handshake. They use private public key encryption to authenticate the server and the host, and they use symmetric key to encrypt the session. They don't use public key, private key to encrypt the entire session because it's usually nowadays 2048 bits, which is much longer. So using a small version, 256 bits of session ID using a symmetric encryption, it's much faster. So mostly used symmetric encryption nowadays is AES, Advanced Encryption Standard, which replaced the old encryption technique, DES, which stands for Data Encryption Standard. Now let's talk about hashing. So hashing is the practice of using an algorithm to map the data of any size to a fixed length. And this is called the hash value or hash sums, or sometimes checksums or hash digest. So encryption is a two-way function where one encrypts the message and the other party decrypts it using a public-private key or the shared key. Whereas hashing is a one-way function. So you cannot reverse hash to generate the data. You can only generate the hash value of the data and compare with the given hash and match the output. If it matches, then you can confirm the integrity of the data is intact. And if not, then data was altered or it's not the same data that you received. So encryption is to protect the data in transit, but hashing is a way to verify that the data has not been altered in the transit. So it serves as a checksum. And SHA and MD5 are probably the most common used hashing algorithm. So for example, if you're using a SHA-256, which is also known as SHA-2 hashing algorithm, SHA stands for Secure Hash Algorithm, it's going to give you the output of hash value that is 256 bits and is represented in 64-character hexadecimal string. You could provide this hash value to the other party, and once they receive the data, they would also use the same algorithm to produce the hash value, and if both match, then they can confirm that the data has not been altered. It's very popular when downloading software or ISO file, especially if the software company provides you the hash value. So for example, if you download Kali Linux, the new one, they have this hash value, SHA-256. What you can do is you can use, if you're using Windows, if you're downloading on Windows, you can use setuid hash file and then just give the location of the hash file. Kali, and ours is 256 SHA hash, so you just give the algorithm, and when you enter, it will generate the 256 bit SHA hash value, and if it matches with the hash value given on the Kali website, then you know that your downloaded was not corrupted. And you can use the same method in Linux also. In Linux, you can just do SHA-256 sum and file name, for example. So it just generates the hash value. And same command is true for Red Hat too. You can use the same command here too. SHA-256 sum, and we can use the same shift algorithm. So you just give the algorithm name and the name of the file, then it will just generate the hash value, and you compare this hash value with the given. So hash value command completed successfully, ending with 67DD704DE. Yeah, so it matches with the information. So that's how you know that your file was not corrupted or altered during the download. So every file or the data, this should produce a different hash value. And if two files produce the same hash value, then it's called a collision, which makes the algorithm useless. In 2017, Google created collision with SHA-1, but before that, it was already replaced by SHA-2. So they just had to make a point. So now let's talk about salting. So salting is a concept that typically refers to a password hashing technique. So hashing, you can generate the hash of the file, but you can also generate the hash of the string. So salting usually refers to the hashing technique that we use in the password. So essentially, it's a unique value that can be added to the end of the password to create a different hash value. So it adds a layer of security to the hashing process, especially against the brute force. So what happens is, let's say your password is plain text, for example, Linux. Then a person can guess that password and generate the hash value and compare the hash value. And if that guess is right, and if the hash matches, then the person can confirm that your password is Linux. So that's like a dictionary attack or brute force. When you add a different random salt at the end of the password and generate a hash, so even if they guess your password, they cannot generate the same hash value without knowing the salt value. So and the salt value, you should have a random salt value for each user. So the guessing will be very difficult. So it just adds a layer of security to the hashing process. When salting, the additional value is referred to as a salt. And the idea is that by adding a salt to the end of the password, then hashing it, you have just complicated the password cracking process. That's all. So when Unix was first developed, they used to store salted password in etc's passwd file, but during 1970s. But in 1980s and later, they changed it. They changed the password storing file, and now they store in the etc SATA file. It's because the etc passwd file is readable by. So if you do long listing of passwd file, the file has a read and write access for the root and read access for other users. So other user and system, they have to read the information inside the file to give, let's say I'm logged in as me. My home directory is /home/umesh. And if we read this file and let information about me, so here on this one, that's a home directory of the user. So if other user, the system cannot read this file, they cannot give me the home directory. And this is because the read permission is allowed for other users. So since this file is readable by many users and processes, storing the password on this file was risky. So they move it to shadow file, and the password is stored as a hash value. So this is the password field. So in this example, this is the salt, which you will add at the end of the password to create a more complex password. And this is your hash value of the password. So let's talk about this different fields, and we'll go about this one more in detail. So the first field is the name of the username. The second field is your hashed password, salted hash password. The third field is date of the last password change. So let's go and change the password. Okay, now let's go and check that file. So now this field has been changed. So this field records the number of days since the user's password was changed. And to calculate the number, it uses a January 1st, 1970 as a starting date. That day is also known as a epoch time or epoch day. Let's say, for example, you can convert that date to today's date. For example, if you just simply type date, it'll display the today's date. And let's say, and to find this, since this day was represented as a number of days since January 1st, 1970, we can calculate the exact date by using date command. Date -d 1970 0101. So that's the epoch day, epoch time. Since this day, it will calculate the number of days the password was changed, and 18708 days. So since then, our password was changed because we just changed the password. And the fourth field is the minimum required days between the password change. If it's 0, then there is no minimum days. You can change password anytime. And the fifth day is maximum allowed days between the password change. So once password is changed, the user must have to change his or her password again before this field. So in this case, the default value is 99999. So you can change it anytime. And the sixth field is number of days in advance to display a password expiration message. So if your password is expiring, let's say after 20 days, before on 13th day, it will start giving you the password expiration message. And the seventh field is number of days after password expiration to disable the account. So for example, if your password is expired and the days and the number is 3 here, so after 3 days of your password expiration, your account will be disabled. And the eighth field is account expiration date. If you want to set expiration date as today, then you just use this many days here. And after today, the account will be expired. And the ninth field is reserve. It's not being used yet. It's reserved for the future use. So those are the fields for this line in etc shadow file. So now let's talk about this salted password. This is the topic of interest for today's video. So this field, the second field, is the hashed password, but it is represented in a form. So usually this form is $ID, $salt value, $password. So usually in this form. So in this case, 6 is the ID, this is the salt value, and this is your actual password, hashed password. So for example, in this case, the 6 represents SHA 512 algorithm. If it was 1, then it represents MD5 hashing algorithm, 2 Blowfish, 5 SHA 256, and 6 is SHA 512 algorithm. Let's say somebody got hold of this information. If the person can guess your password, then they can generate a hash because the salt value is already here. So let's say, for example, and we're generating the password. So use password command -6 because we're trying to generate a SHA 512 sum of your password. And now we already know the salt value. So we're gonna copy this salt value and paste it here. Enter. Now it's asking me for my password. Oh, I changed it. I forgot. Sorry, my mistake. Now it's asking for the password to generate this hash value. In this case, that is the same because we're trying to generate a hash value of my password. See this one, the exact match. So up to here, it's a salt value, same. And from here, this is the hash value of my password. So let's say I use a different salt value. Let's say I change some, let's say number 4 here. And now, even if I enter the same password, the hashed information will be different. Up to here, everything is same. except I changed this last letter from 3 to 4. Now it's going to change the entire password field. So that's how salt will create a complication in password guessing. And given the fact that the attacker does not have this information with them, it's very hard to guess and regenerate your password. Some distribution which I noticed in Kali Linux, they use a different hashing algorithm, salting algorithm. Let's check it out. So if I do sudo cat header file, so here there's a Y instead of 1, 2, 5, and 6. So Y means yes script. So this is a newly adapted cryptography function to generate a salted password. If you do, and it uses this cryptlib function. So if you go down here on the manual page, go backward. The first option was yes script. So it's a hashing algorithm, and it uses this format. So Y means yes script, and you can generate a yes script using the command mkpasswd method yes script, and hit enter, and just keep the password that you want to generate the yes script information, and this is how it generates the yes script information. And you can also do SHA52 up here. You can also give the salt value. Let's say ask you for the password, and it generates the 6 is SHA512, and with the salt value and your actual hash password. You can see what method are available with this function. And if you do, see, it uses the given password with the cryptlib function. Let's do and quit. So this is it for today. In my next video, or maybe a video after that, I'm going to talk more on cryptography, encryption, SSL, and especially SSH and SSH key authentication. And we'll talk more in detail about SSL handshake and how it uses asymmetric and symmetric cryptography or encryption to create a session and encrypt the session information. I hope you find this video helpful, and I'm hoping to see you in the next video.